All right, I'm going to go ahead and share my whole screen here. And we're going to just kick off the MASH crash cushion. Again, probably going to try to stick to the time schedule and move fairly quickly through each of these slides. So hopefully you can see that okay. Trinity Highway has been in the highway safety business for a long time, preceding even the 1990s. Energy absorption systems was essentially the pioneer of the crash cushion. So, energy absorption actually started in 1969 and developed numerous crash cushions over the years. Um, so I don't have the dates right in front of me, but essentially MASH was developed as the most recent crash standard. And it was kind of developed around 2009, 2010, but it essentially came into effect around 2016 with a introduction from the Federal Highway and AASHTO for a implementation in the future. And the dates have been kind of fluid as we've gone through time and with the availability and unavailability of certain products. The MASH crash cushions, for instance, some products are not quite available yet. Some wide versions, wider than the systems I'll discuss today that we've developed. But that's kind of the latest crash standard. The quad guard, which we'll mainly focus on today, was actually developed in 1995, right about the same time that the NCHRP 350 crash standard was developed and introduced. So that was the most recent crash standard before this MASH compliance standard. It's the Manual for Assessing Safety Hardware is what MASH stands for. And again, it is a very long book of very detailed requirements for testing all the various roadside hardware products that you see out there. So crash cushions is just one of the products. Sign supports is another product, for instance. Truck mounted attenuators, which we also make for work zone safety protection. Those are another separate item that's addressed, as well as guardrails, guardrail terminals, concrete barriers, cable barriers. There's numerous items that MASH is the crash standard for. And today we're just going to kind of focus on our crash cushions. And again, these are all derivatives of the original quad guard system. So it's a quad guard crash cushion family is what we typically refer to it as. And as we get into these, I'll kind of go into some of the new names for these. Crash cushions are typically a redirective non-gating end terminal, often referred to as well as impact attenuators. I would say that's more common in the specifications to be called an impact attenuator, but we typically call them crash cushions. So we have the first iteration of the standard quad guard for MASH was called the quad guard M10. And if you look below, you'll see the M10 is the model for narrow with 3 R's there. But anyway, so we have a narrow unit that's 24-inch wide, and we offer the test level 2, which is approximately 44 miles per hour, and then the test level 3, which is tested at 62 miles per hour. When we were going through the product development here, we originally called these M10 because 2010 is when they were originally going to introduce MASH. Because they didn't make it a requirement, it wasn't adopted by many states. And so that date kind of slipped. And again, it ended up being about 2018, then 2019, where they introduced specifications to require MASH in most states. But it's been kind of a moving target. What we did, though, is we redeveloped our wide system at 69-inch wide. And instead of calling it the M10 as well, we called it the Quad Guard M. And so the QuadGuard M wide is our 69-inch version, and that's available as a TL3 unit. The unit I'm most excited about in this family is the QuadGuard M10 Elite. So this was actually developed quite a while ago as well. And we have both a 24-inch wide narrow system and then a 69-inch wide system as well. Both those systems are just certified at test level 3 only. We have certification at TL2, but at this time we haven't introduced that product to the market, and I'm not sure that we will at this time. So that's something that remains to be seen. But that's kind of a general introduction. You know, and if you have questions, it's okay to speak up and stop me and let me know if you have a specific question you want to ask as we kind of go through this. Feel free to interrupt and just show an impact attenuator primary applications. You know, typically they're on higher speed roadways. That's why we've tended towards the test level 3 versions. You know, they'll primarily you'll see them in gore areas on the major freeways, interstates, or busy highways. Here's just a few examples of gore area applications, kind of protecting different barriers, bridge rails, W-beam, guardrail, and safety shape type concrete barriers. You know, another common application of the impact attenuators or crash cushions is to protect a roadside barrier. Frequently, these would be concrete barriers, but also on the roadside, again, with the QuadGuard system. The one in the lower right corner there is a QuadGuard M10. That is a MASH system there, and that's actually relatively close to my home in North Idaho. On I believe that's the Sherman Street exit off of eastbound I-90 or westbound. Sorry, you can see the sign even. But
what are some other differences between the 24-inch versus 69-inch width? Is it the length?
No, the length is going to be the same. Primarily, I believe there's 1 inch difference because it's a tapered system, so it ends up being a little shorter. It's just the flare rate, and I'll show you kind of a diagram or a drawing that shows that. So the wide system has different shape or different width diaphragms. As the system goes back, it gets wider. And it's designed to protect the wider hazard. There's some subtle differences as well. I wasn't going to get into the exact specifics of those today. I can certainly do that, or if you have specific questions, we could exchange emails or something later. But for instance, the wide systems do have a hinge to allow the fender panels to flare out where they attach to the diaphragms, whereas the narrow systems, since the fender panels slide directly backwards, they just attach directly to the diaphragm. But with the wide system, you have a little hinge that allows it to flare out slightly. So in both cases, the number of bays, and I'll show you some slides with bays and kind of count those for the different systems here, but the bay count is the same for the narrow and the wide systems. And then the transitions will vary slightly, and I'll talk about those as well. So here's, again, just another application. This is a median concrete barrier. In this case, they have a need to U-turn snow plows in the median. So they've had a concrete barrier opening, and they have crash cushions protecting each end in the median there. And then again, here's a fixed hazard bridge pier in the middle of I-90. This is in Post Falls, Idaho. So that just kind of gives you a few applications of the various units. And again, I think you can see these are wider units. It's hard to tell, but these are most likely 69-inch wide units. Whereas here, you have a narrow system protecting a guardrail system that comes together. And this is at an exit in Spokane, Washington off of I-90. So the QuadGuard M10, it's a very relatively simple system. I believe, obviously I work with it every day, but it's pretty straightforward. Here you can see the system, and I'll get into some diagrams on it in just a minute here. But here's we call it the effective length. So that's where it redirects a car on a side angle type impact. The system length, if you look down in this chart, hopefully you can see it. It's right about 22 feet, and I just put 22 feet on the slide. We also have the TL2 version, the 44 mile per hour unit that's available, and that's going to be 13 feet, essentially 12 feet 11 for the system length. So again, those are the two systems we're offering in a narrow unit right now. This drawing kind of depicts both with a line in the middle to show that it might not be the full length. But here's the kind of the components of a quad guard system. What we call the backup is it's a standalone system that's mounted to the concrete foundation pad, and that's going to absorb the energy as the system gets impacted. It'll telescope backwards and crush these cartridges. That eventually the load gets transferred to that backup unit there at the back of the system. And then there's a monorail that you can't see here that runs underneath the whole system, and that keeps the system in line. It also provides a redirective capability. So as a vehicle would come in an angle impact to the side, it will impact the quad beam fender panels. That load gets transferred to these diaphragms that are in between each bay of the system. And then that load from the diaphragm gets transferred to that monorail base. And so that will absorb the redirective load and redirect the vehicle on its path back towards its original trajectory. So the cartridges are what absorb the energy in a head-on type of impact. The steel nose at the front of the system is going to support one more cartridge. So this is what we call a 6-bay system, and this would be with 7 cartridges. So we don't count this as a bay, but with this 6-bay system, we have 7 cartridges to absorb the energy. And this is anchored to the roadway with the anchor studs, typically a 7-inch anchor stud that's 5.5 inches embedded into the concrete foundation pad. Just, I kind of skipped over it, but you can see the concrete foundation pad in this detail. We recommend a reinforced concrete pad in most applications, especially in the areas that have freeze thaw occurring. One of the changes we've made with the QuadGuard M10, just to note it as well, is we used to require and ask for this concrete block to be at the front of the system. Over our numerous crash tests that we've ran through the MASH certification process, we decided this was better placed at the back of the system. So we recommend it's at the back of the system. It will function and the system will perform fine with it at the front of the system. It's just something that for long-term maintenance of the pad, we feel it's a better location there, and it'll ensure the pad holds up longer. Because in some cases, there are a lot of forces that are exerted on the monorail and backup that are installed on that pad. So, they're crash tested with a pickup truck and a small car. In the real world, you can get these impacted by semis or box vans that are running at 70 miles an hour, and you can see some pretty interesting results on those tests that are outside the design parameters of the MASH criteria. So again, just to summarize the standard QuadGuard system, we have the TL2 version, we have the TL3 version in the 24-inch application, and then we have a 69-inch system that is test level 3 only at this time. Again, they're roughly 22 feet in length. The TL2 unit is 13 feet in length. The top of the panel height is roughly right around 32 inches. And so these are configurable for unidirectional applications like a gore area, or bidirectional applications like a median area, or a 2-lane, 2-way highway with, typically you'll see these on bridge ends. and you'll have two-way traffic so that the backside is exposed to traffic as well. And that's when you need a transition. So these transition options we have allow us to protect various hazards while providing a redirective component on the backside so that if a car comes in the back, it will redirect away from the back of the unit and not get snagged there. So guardrails, temporary or concrete permanent barriers, vertical concrete walls, certain types of blocks or bridge rails, and then tri-beam installations as well. So I'll get in more detail on those. Here's just kind of a snapshot of the TL2 system. So again, it uses 4 cartridges. It's a 3-bay system with 1 bay or 1 extra cartridge in the nose. And I didn't mention it, but there's 2 types of cartridges. Type 1, which is a lighter weight cartridge, and then a type 2 cartridge further back in the system. So these are more resistant, so it'll be a little softer as the vehicle impacts it from the front, and then more resistant near the back to slow the vehicle down safely and bring it to a controlled stop. So here's, hopefully you can see this.
Are they sealed?
I'm sorry, go ahead.
Are the cartridges sealed?
Yeah, they're not sealed so that like if you submerged them in water, there would be water that would probably penetrate through the sides, but they're sealed with a tight cover and they're riveted closed so that no water should get into them, rainwater or anything like that. I'm going to run this again. Hopefully you guys were able to see this crash test. It's pretty quick, but you can kind of see how the system telescopes back. The cartridges are crushed. And typically, with a seal nose, it's damaged to the point where it needs to be replaced as well. But the idea is to come in here, pull these systems back out, replace the cartridges, put a new nose assembly on it, and replace that cartridge as well. And then it's ready to be back in service. This kind of shows you a different type of, again, there's eight crash tests that are required as part of the MASH compliance verification. This is one of the tests. I believe this is called 333 in the matrix. And so this is roughly a 15-degree angle at the nose at 62 miles an hour. So keep that in mind because most of these videos are in slow motion. But you can see instead of allowing that vehicle to pass through, it actually kind of catches the vehicle and brings it to a controlled stop. There's no rolling of the vehicle or, there's even a maximum pitch angle that it can rotate up to where the MASH criteria allows it to be considered successful. So you can kind of see in this, normally it might go right through that, but with a crash cushion, it's going to catch the vehicle and bring it to a controlled stop. So again, I kind of touched on these earlier, but we have the MASH quad guard to safety shape concrete barrier transition, single slope barriers, which tend to be more common these days, at least in some specific states, Washington and California specifically, I guess. Tri-beam, that's actually still pretty popular in California. I'm not too sure of many other states around here that use it, but that typically will start a transition into a rigid hazard like a bridge rail. And then we have what we call end shoes to attach to vertical concrete wall. And I'll show you some examples of those. So here's a jersey type or safety shape barrier. And here's the transition attaching. So you actually need to line the quad guard up so that it's offset. It's not going to be centered on that barrier. In a unidirectional gore application, you would probably center it on that barrier. But in this case, where you have traffic on the backside, you'll want to offset the system so that the transition lines up properly and attaches to the barrier correctly and attaches to quad guard correctly as well. So again, here's just a, kind of a view through the front of the system of how the system could be offset. And then there's an overhead view where the system attaches. What's a little bit unique about these new MASH transitions is this is all one weldment. So this little brace here is welded and it's part of the whole panel, as well as this block out here. I'm sorry?
That the water has to be filled up to a certain point.
I had a question, Michael.
Yes.
So all of our former precast concrete barrier was the jersey shape, but anything new installation is supposed to be a new F shape according to our standard drawings. Are there different transitions for the F shape versus the old jersey shape?
No, there's enough kind of play, and there's not that big of a difference where we have different transition pieces for those. So it is the same safety shape.
Okay,
They're both
thank
safety
you.
shape barriers, and so we use the same transition for those.
Okay, thank you.
Just another note, and this gives you a picture of the transition there to concrete barrier. Again, that safety shape transition. With a portable type concrete barrier, you do want to anchor that barrier, because when a vehicle comes in, and you can see the projected path for the MASH testing here, that little dashed line down there. When that vehicle hits that barrier would normally rotate if it was just a portable concrete barrier, but you want it anchored to the pavement so that it does not slide and you don't get any pocketing, and the vehicle's redirected safely away from the back of the unit there. So here's a drawing of our tri-beam transition. So if you're going from a quad guard to a tri-beam, there is a separate component there, a bracket, and that bracket's going to go in between the panel and the quad guard backup, and you can see these attaching here, and then it's going to attach to the tri-beam shape at the back there, supported essentially by 4 posts. And I got I think a picture of it here, so you can see it's this section here. It attaches underneath this sliding panel here to the quad guard backup, and then here it transitions to the tri-beam. So there's that transition piece, again, prior to a crash test. We also have that same transition piece. You can see it here. It's a lot smaller in this picture, but then it transitions to the tri-beam, and then uses a tri-beam to W-beam reducer element to tie it into MGS type of guardrail configuration. So here's kind of a plan in our manual that shows that. So again, just to show you how you can tie into different types of flexible or semi-rigid barriers, both the tri-beam and W-beam. And here's the end shoe. So this is attaching to a vertical wall. What we show here with this concrete block, the wall is tapered. So there's one concern that on a front direction impact here, there could be some wheel snag right at that location where the system ends. And that's why we recommend you taper this concrete wall. If you're not able to taper the wall, and that's what we're showing here, this it's a weldment that's attached to the concrete wall, and we call it a wheel deflector. So rather than taper the concrete barrier, we offer another option, which is called the wheel deflector, to ensure that that vehicle, as it hits into this square concrete wall, it doesn't snag its wheel on that and get hung up and have extra force that is undesirable for the crash test, so, or the real life impact. All right, well, here's the 69-inch wide system, and I'll run through this rather quickly. Again, it's very similar. You can't really see them in this pictorial here, but there is an additional hinge plate, and it's just it's a piece of steel that's the same dimension as the edge of the diaphragm there, and there is one of those attached to each side of the diaphragm, so those panels will flare out slightly. Very similar. Other than that, the monorail base and backups are the same, except for this last diaphragm back here is part of the backup. So the width of that backup is much wider. But the fender panels are the same. The cartridges are the same. The nose is slightly different to allow a little wider attachment, because this diaphragm is slightly over 24 inches right at the front of the system. There's kind of a head-on camera view, so you can see it's a straight flare on each side. In the old quad guard system, this front section used to be wider. I want to say it was close to 39 inches, that front diaphragm. This front diaphragm is right around 26 to 28 inches wide. I'd honestly have to look at a drawing to get the exact dimension, but so this new quad guard M wide is narrower at the front, obviously the same 69-inch wide at the back. And there's a shot from the manual again with the transition to the safety shape type concrete barrier. And you can still see that, the same weldment where it has a brace there and a block out attached to the transition panel. And again, the same, concrete pad requirements, whether it's a narrow or a wide system as well. Here's just a view of the transition to W-beam. Again, you saw a picture of that just recently with the standard quad guard system. Here's with the quad guard wide system. Again, following in line with the taper. If you needed to get to a wider hazard, and you have the length in front of the system or in front of the hazard, you can flare these systems out with the guardrail or W-beam that runs behind it, so that you can get to a wider hazard if you had something here that was larger than 69-inch width. And again, here we're just showing an end shoe. This is, we depict what I call a 69-inch existing block. So there's, a lot of crash cushions out there that were poured with the concrete block like this as the backup. Both systems might have a block like that. So this system can be used in front of one of those existing blocks. And that just depicts that installation there with the end shoes there to protect both a impact coming at the last minute at the back of the system, or if you have the two-way traffic, which we depict here, somebody coming into the back of the system here would deflect off this and be redirected away from the back of the unit. So, just to summarize our quad guard M10 and the quad guard M wide, it's MASH compliant. We have the FHWA eligibility on both these systems, essentially all three systems, with the TL2 system and the TL3 system in the narrow application, and then the TL3 system in the wide application. The quad guard's proven performance. It's been out there again since 1995, so over 25 years the system's been in use. Again, to the NCHRP Report 350 standard, and now to the MASH standard. A lot of the maintenance people out there are familiar with the system, know how to work it. I think, one of the things about the quad guard that's really nice is it's easy to repair. And part of that, I think, is it's intuitive how it works. The cartridges get crushed in a kind of an accordion fashion. You pull the system back out and you replace the cartridges. If you need to disassemble a fender panel, it can be replaced, or if you have a bent, damaged diaphragm, you can take it apart at that site and replace a diaphragm. But the system overall is relatively easy to repair, and it's pretty easy to understand how it works and what it does. So we have the multiple transitions available for the various applications you might come across. So any questions just on the standard quad guard?
Not from me.
Okay, sounds good. Well, I'm going to keep rolling here, and I'm going to get into the quad guard Elite M10. Again, this is our kind of premier system, if you will. It's the low maintenance system. Also has what we call self-restoring features, and it's a neat system. It's an 8-bay design, so you can see here what it does is it uses these elastomeric or high-density polyethylene cylinders to absorb the energy. So you can see at the front of the system has a lighter wall cylinder. Then get into the back of the system, we have heavier cylinders with laminates inside them. So again, those are designed to absorb the energy and resist the vehicle traveling into it at up to 62 miles an hour. They're labeled as 3 different types of cylinders: an ME1 in the front bay, and there's actually also a cylinder in the nose that absorbs some energy. This ME1 cylinder is the same cylinder as ME2. It just has a different bolting pattern to attach to the front of the system. So that's why it is called an ME1. During the assembly, you'll want to make sure that one's there to attach to that front diaphragm, whereas the rest of these are attached through the diaphragms. And I think I have a slide to show you that. But again, same monorail design with the backup, same fender panels. So there are a lot of similarities. The diaphragms are essentially the same as well. So there you can see the 69-inch wide quad guard Elite M10. Again, uses the same cylinder configuration, same types of cylinders. There you can see a drawing of that system. Now these are a little bit longer with the 8 bays. They're out at 27 foot 1 inch in this case with the wide system. Again, they're both MASH compliant. Excuse me, an 8-bay system. So we offer the 24-inch wide system and then the 69-inch wide, and that's inside panel to inside panel designed for that type or width of hazard. Excuse me. So they go through both small car testing and what is essentially a crew cab pickup truck, 5,000 pounds. This vehicle here is, I believe, right around 2,200 pounds. And then they also take on, whoops, all right, there we go. A 25-degree impact angle on the side for a redirective test. So again, these are acceptable in both unidirectional and bidirectional applications. Again, same standard monorail and fender panels. The one thing about this system that's unique is it has a high degree of residual capacity, and I'll demonstrate that by showing you some slides of the crash tests. But essentially, these can take multiple impacts, even without reset or repair in some cases. Now, we always recommend a maintenance crew go out and inspect the system and do any repairs. They also want to reset these systems, and that includes stretching it back to its original length for a period of time. But we have low post-impact repair cost and an overall low life cycle cost. Again, the system is essentially 27 feet 2 inches in the case of the narrow system. The cylinders are bolted to each diaphragm, and I think I got a slide to depict that. Again, I talked about the 3 different types of cylinders that are used. Essentially, the ME2 and the ME3 cylinders are the 2 varying wall thicknesses. As the ME3 cylinders have the laminates, and that provides added resistance or strength. What we've also done with the diaphragms in between each system for the Elite, it has an extension on top of it. I think I've got some slides to show you that. Here's just a side view of the system and an overhead view. Again, we've talked about this, and so I won't spend a lot of time on it, but one thing I haven't mentioned is it's the belt nose. So this system being low maintenance, rather than have the steel nose, this is essentially like conveyor belt, but it's material that's designed to withstand impact and be reusable after vehicle impacts the front of the system. Again, we're using the same quad beam fender panel on the sides and same monorail base with tension strut backup. The other thing you'll see here in orange is what we call a hit indicator. Because these have a tendency to reset themselves, we want you to know that it was impacted. So as this vehicle comes into it and that bay gets pushed back, there's a spring load here at the front of the first diaphragm that will actually push that post up. Has a little hook there on the second diaphragm that holds it in place until that diaphragm is slid back, and then it'll pop that impact indicator up so that you can know that it was impacted and go out there and take a look at it and do some maintenance and reset the system. So again, here you can see what we call a diaphragm and backup extension. That just ensures that that cylinder interacts with the diaphragm better and absorbs as much energy as possible. So here you can see how two cylinders are installed together. So they're going to bolt through the diaphragm. And you can see there's two long bolts with a washer plate on the back side here that you can't see, but essentially it's a heavy bolt and hardware to attach each diaphragm to attach each cylinder to the diaphragms. So this will show you how the system absorbs the energy, how these cylinders will reshape themselves to absorb the energy. And again, this truck is traveling at 62 miles an hour. So there is a lot of energy, and you can see the impact indicator post has released from that diaphragm. But these cylinders, they want to reshape themselves. So they'll start to reshape themselves even with the weight of that vehicle. The system's able to push itself back into near the original configuration. So just, that same crash test that you just viewed, here's kind of a summary of it. One of the things I like to point out is the limit that MASH allows is 20 Gs of negative force on the occupants of the vehicle. With this system, we were at 13.1 Gs. So that's a very low number, lower than any type of system like this that I've seen. So that suggests it either has extra capacity or could possibly take a little higher speed impact and still meet the MASH criteria. But I think that's a pretty interesting thing to note in this system. And then the reusable cylinders, I like to demonstrate and show how they reshape themselves. The real benefit you'll see here is the residual capacity. So as this vehicle comes in, the energy is absorbed, the vehicle's brought to a stop. It does push it back slightly, but again, the system resets itself to nearly 85%. So here's the post-impact picture of that crash test. The system's out at about 85% of its original length. Again, the maintenance guys will want to come in, pull this out further, stretch it to its original length. If you hold it in place about 15 or 20 minutes, that should be enough to get it to do that. But a lot of times these impact attenuators are not quite, repaired the same day, or even sometimes that within 2 or 3 days. Ideally that's the case, but depending on the situation, the maintenance guys may have a hard time getting to the site if it's in a gore area on a busy freeway, or they just might not have the manpower, or they may not be aware that it was impacted in certain cases. But if a vehicle would come along and impact this again, it's offering some residual capacity that would prevent, hopefully prevent significant injuries to the occupants that would hit it. So again, there's just a post-impact picture, and you can see the impact indicator up on the post, again, to alert maintenance that they should take a look at it. So just real quick here, this is the wide system. So this is 69-inch wide at the back here. Again, 8-bay system, same cylinder configuration. And I just wanted to show you that it's got the same potential in the wide system. So here you can see, again, a 5,000-pound pickup truck coming into it at 62 miles an hour. It absorbs the energy, brings that vehicle to a controlled stop, and then it pushes itself back out. So again, I think these crash tests are pretty impressive, and it's a feature that, to my knowledge, no other MASH product has at this time. Again, we're going to be in the same category, and that's, what's nice about the QuadGuard Elite and the QuadGuard family. Original QuadGuards, they can typically utilize the same transitions. So we have those same safety shape type barrier transitions. We can allow for different configurations of that barrier as well. So we have a straight back barrier here in this case. And then in this case, we're showing a flared barrier. So we've done testing to demonstrate both of these designs are acceptable. Again, here's a guardrail system behind a QuadGuard Elite. Here in this case, we're showing a Thri-beam system, but at this point here, it could easily be transitioned to a W-beam system as well. And the manual has all the drawings that depict that. And just again, to summarize the QuadGuard Elite M10, we have the 24-inch and 69-inch wide systems. Again, it's the same proven QuadGuard performance. It is a low maintenance system that offers high residual capacity. And it's what you want to use in high impact areas. So, states will use different standards. If you expect an impact more than once every 1 year or every 18 months, it's definitely something you would want to consider. And even up to, I think, 3 or 4 years, I think you're going to see the return on the investment. There's just roughly 30% price difference between the QuadGuard Elite. So I would say, if you have the space to install the system, it is a really good choice. And again, we have the same, transitions that we've talked about. Just to kind of tease a little bit, I guess, and this has been released by the FHWA. We have an eligibility letter for our sand barrels. We call the Energite. And it's exactly the same sand barrel that we've been making for the last 30 plus years. It uses an inner cone that holds the sand at a certain height to allow for graduated weight of the sand. So typically the front Energite barrel will have 200 pounds of sand in it. As you move back in the array of sand barrels that will protect a hazard, you have a 400-pound sand barrel, and then 700-pound sand barrels. And then a 1,400-pound sand barrel is completely filled with sand. And then we have a larger sand barrel that goes at 2,100 pounds. What you use in a test level 3, and that's all we've done is testing of the Energite at test level 3, is a 12 barrel configuration. And that, is freeway speed of 62 miles per hour. Again, this is another product that offers the same kind of self-restoring features and high residual capacity. The React M, we call it, which is the React MASH system. If you've seen the black cylinders that are approximately 36-inch wide, roughly, I believe, 54 inches tall, those cylinders are common in the Puget Sound area. Actually common over here in the Spokane area as well. Of Washington, California uses a lot of the React system, and they're a low maintenance system. We are just submitting to the FHWA. We've completed all our crash testing and are in the process of seeking FHWA approval, and we'll be coming to the states for approval of that product very soon as well. And then we just have a lot of other products that we are developing right now. And as these MASH standards, have been adopted by the states, that's pushed us to move forward with product development. So we're continuing to pursue new products and existing products that, can meet the MASH standard.
So with that, I'd like to say thank you for joining our Coffee with Coral session. If you have any questions, please feel free to reach out to us. Thanks, everybody.
Thank you, everybody.